In the previous tutorials, we have set up a bank project. Let me give you some review from the file system. So this is where we store our bank projects, and we have 3 directories. Each one of them has been created with a symbolic name as a cluster in the iPhone Studio. So we have the bank to store the business logic, and we have the root, which stores the application class, which serves as the entry point for execution. And we have the tests directory or cluster for storing all the test cases. And ifgens is the directory where iPhone compiler stores the generated C++ code. And docs is where we store the user requirements. So this is for the documentation purpose. At the moment, because we have not created any symbolic name as a cluster for that, so it is not visible from the iPhone Studio. If you like, you can set it up yourself. And from the previous tutorial, we actually have added a test account class, which defines a test Boolean feature called test account creation in the test account class. And we actually have tried to play with how to play with the value of the results of the test account creation. Let me just give you some reminder here. If we double click, this is not really iPhone Studio, but I just want to draw your attention to its definition. So test account creation is a Boolean query, and it declares a local variable of type account. And in there, in the body of the test case, first, most importantly, we actually have to use the comment clause, the comment feature that is inherited from the ES test to actually document what the test intention is, so that it can be reflected in the generated report. And we also show that how we can manipulate the objects of accounts by calling its constructor using the creation instruction in iPhone. And then, because it's actually a Boolean, you actually return something. So a result keyword in iPhone is reserved for capturing the value for the return value. Whatever value that's last assigned to this result keyword will be treated as the return value for this Boolean query. And this is actually a Boolean expression that consists of 2 equality tests. And we are joining the 2 results by a conjunction. And let me close this file. And you can see that some HTML files has been generated. Let's have a look at the one that corresponds to the top level file. Let's go to the application file. And here it shows that here the test suite that is contained in the application class has so far included 1 test case. And you can see that this line here is where the common feature I just mentioned. Let me just bring you back there. If you go to the test account class, you can see that under the test account creation, we actually put a comment feature call. Whatever that's put within this string arguments will be used over here. So that's why it's really absolutely critical for you to document your test case appropriately, so that when you actually look at the test report, you can actually immediately see what this row actually represents, how this row can be traced back to your original test class. Okay, so this is what we have achieved so far. In this tutorial, I'm actually going to show you, because it's often the case that you may want to, let's say, for example, in the test account class, you may want to combine. So this is only 1 test case. But sometimes you may actually want to group similar mini cases into 1 single test case, rather than creating several versions of the test account creation. For example, you might do test account creation 1, test account creation 2, test account creation 3, and so on. What you can do is it's actually up to your judgment. Sometimes it actually makes sense to group similar mini test cases into a single test Boolean query. I'm going to show you how. That's the purpose of this tutorial. Okay, so let's again go to terminal and make sure I am in my 3311 workspace, and then eStudio 1501. So this 1501 is the version for summer 2012. And if you're running a later semester course, make sure you actually launch the iFlow Studio with the correct version. And with the ampersand to make sure you run the iFlow Studio in the background. Enter, open the iFlow Studio, and now we can actually open this existing projects as opposed to creating a brand new projects. Okay, we can open that. Okay, so for this tutorial, we are actually going to modify mainly the test account class. Let me just remind you a little bit how the testing infrastructure has been set up. So first of all, for each class in your business logic, for example, let's say in this case the account, for each class in your business logic cluster, you have to create at least one test class that's dedicated for its testing. In this case, for account, we have a test account class created. In that particular test class, you always have to inherit from ES_test. And once you inherit from there, you got several facilities available to you for you to set up the infrastructure for testing. The first one is, for each Boolean test query, you have the comments feature available to you to actually document your test case so that your documentation will be reflected in the final generated test report as an HTML file when it's shown on the browser. And the second facility is you can actually have the ability to add all the Boolean queries or all the features that return the Boolean value as a Boolean test case. So this is also available from the ES_test. And of course, you can define as many test feature as you like, as you see fit, and then you can add the ones you think that should be tested in the make feature over here. Okay, and also we use the feature bookmark mechanisms to make sure you can actually have a good structure of your file. So when you actually get, for example, when you get to maybe hundreds of test cases in a single file, you can easily navigate them by within the features panel. So you can see that currently we have the make and we have the test account creation. Okay, so this is on the side of the individual test case. Once you have, let's say you have test account, test transaction, test bank, and you want to somehow combine them into a single suite. The way to do that is to go to the main class that has been set as the root. So in this case, we have set the application class as the root. If you want to modify the setting, you can go to project setting to say, I want to set another class to be the root class. So for whatever the root class is, you have to make sure it inherits from the ES suite. So it can then use the facilities that's inherited from the ES suite class. Particularly, we are going to use three features. The first one is we can add the test case. So each add test is expecting some ES_test entity, and because test account is actually a descendant class or child class of ES_test. So that's absolutely a very adequate or suitable candidate to be passed in the application class. And this is the notation for creating an anonymous object in iFlow. So the create is the keyword. This is the type of the objects, and we are creating these objects without assigning that to a name of variable. Just basically like a syntactic sugar for creating anonymous objects, like the new notation in Java. The second feature that we use from the ES suite is the show browser. So this makes sure that whenever you actually run the test cases, you will actually display the result as a HTML file in your default browser. And then you also have to make sure you always run the eSpec. Again, eSpec is actually the acronym for IFO specification. To actually, once you have set up the infrastructure, which means you actually somehow connect the business logic with your testing infrastructure, you have to run the test cases. The way to run it is to go to the drop-down menu to the right of the run. There's a down arrow here. Click on that and say run workbench system, and you will actually see, presumably, you should really see a green bar every time you call it a stop for your current developments. Every time if you introduce a new feature or remove a feature from your current developments, you always have to rerun all the existing tests to make sure your current change does not introduce any new issue to your regression tests. That's really the essence of test-driven development. Okay, so in this tutorial, we are going to show you some technique to actually write some mini test cases within a single test case, and to make sure you're doing that in a correct way so you don't actually somehow mistakenly ignore some intermediate results. Let me show you what I really mean. So let's use the existing example we have. So currently we simply have a single assignment to the results of this Boolean query. Okay, so let's say somehow we want to let me do the following actually. Let's say the first test case I did was to make sure if I give some specific value for the initial credits, I actually do get the same one. Let's say I also want to test for a specific value. Let's say I also want to test for if I make 20. As I also explained in the previous tutorial, if I call the create, if I apply the create instructions on the same ACC here, so from this line to this line, so here I'm creating a brand new object that's completely different from this one here. As opposed to if I simply say acc.make, this is also valid syntax, also valid as far as the type checking is concerned. In this case, I'm not trying to create any new objects. I'm only trying to set the credits of whatever account that has been created here from 10 to 20. Okay, so maybe a better way to do that would be, maybe I would say ACC2, which is also account. You can either do that, or you can just say ACC and ACC2. So both of them are members of the account class. Okay, so what if I let's do that, and now say ACC2 make some, let's say some very large, much larger credit limits, and make sure it's really properly set. Okay. Okay, so now we are initializing ACC2 with some balance that's some credits that's larger than the previous one, and we want to do some test. So now we assign some proposition that's very similar to this one here. So we can say ACC the balance. And as before, we always expect the initial balance for any new account to be 0. And in this case, because we are passing a much larger credits, so we should expect the credits. So you can see I actually made a typo here. This should be ACC2. So you got to be very careful when you're doing the test case. You always have to review and make sure what you have written really makes sense. So here, because I have just created ACC2, so that means I'm testing ACC2. So here ACC2.credits should be equal to 1,000. Okay, so I certainly should expect this to pass. Compile, and now I want to rerun all the test cases. So now you can see the change I have just introduced is now I'm testing two things. I'm testing first if I initialize an account with initial credits of 10. Second, I'm trying to test another account to be initialized with the credits 1,000. Okay, so let me now run the workbench system from the drop-down menu, from the down arrow to the right of the run here, and then I would say run workbench system. I do have a green bar. However, can you see what's the issue here? Now, we are trying to reassign the value to the results. And as I said before, if there is no contract violation throughout the course of the body implementation of this Boolean query here, then the test results depends on what's the final value or the final value of the results, which will be treated as the return value for test account creation. So in some way, it doesn't really matter what this value is because that's not really the last assignment for results, but this is. So if this assignment to a result is actually true, then the final value or the return value for this feature here will be true. If, let's say, somehow this intermediate reassignment to result is actually false, which means this mini test case is actually not satisfied. But how can we actually tell that? Because if this is actually assigned to be false, but this is reassigned again to be true, so somehow the violation of the mini test case here is overwritten by a later success of the mini test case. So let me give you one example to actually to make my point even clearer. So let's say now I make this guy 20. I'm now saying if I initialize an object called ACC with the initial credits of 10, now I'm expecting the credits after the initialization to be 20. Apparently this 20 does not match the 10 here. So this mini test case should fail. And the whole test case should only pass if all the mini test cases pass. If any of the mini test cases actually fails, then the whole test case should be considered as a failure, right? Okay, so now we agree that because this guy here actually fails, so we should expect a red bar. But let's see if we really get a red bar. Let's recompile and run the workbench system. And we still get a green bar. So there's going to be something we have done wrong. So let me try to explain to you exactly like what I said before. Because this is only one of the reassignments to the results. And we are actually assign. So even though this is actually going to assign a false to the results, but the later proposition actually is going to override this result value here as true. So you can think of this. Right at this point over here, right before we do the second reassignment, result is false. But right after this assignment, the result is overwritten as true. So that's why the final value is true. Okay? So, but we do want to keep we do want to have the flexibility that we can combine such mini cases in a single test account creation because we don't actually want to separate them to be test account creation 1, test account creation 2. So the way to do this is to say if any of the mini cases fail, we are actually going to give some assertion error. To support this, IFO has a syntax to write in code assertion check. So the syntax to follow is if you type check and then press space. Let me show you again. So you do have the code completion support for that. So just type the word check and then space. So now, whatever that's going to be filled in within check and end, so check and end are both keywords, whatever that has to be written within here has to be, again, because it's you can also think of that as a contract, but it's an in-code contract for the implementation. Whatever that has to appear here has to be a Boolean expression, like a proposition. So now I should put this. So this result should be the immediate result from this assignment here. I'm saying this is the mini test case. If this mini test case is actually true, which will make this assertion pass, then I can go ahead and proceed with the second mini test case. However, if this first mini test case assigns false to the result, this will make the check assertion false, because check assertion is expecting some true value here. Otherwise, it's going to throw some contra violation. Okay, and now that's something I have to say again. So let's think about what's really the meaning of treating this test query here as a test case, because we are going to add it as a Boolean test case. So there are several cases to consider. So case 1, if there is no contract violation throughout the course of the body implementation of this feature here, then whether the test case is considered as a success or failure depends on what's the return value of that. If the return value, which corresponds to the last reassigned value for the results, if that's true, is considered as a success. If it is false, then it is considered as a failure. Okay, so these are the first two cases. The third case, if there is any contract violation in the middle of the course of the body implementation, then as soon as the contract violation occurs, then we stop with the test run, and then we immediately say the test run is a failure. So that's exactly what we are trying to do here. So we are saying if this mini test case over here, if that one turns out to be a failure, reflected by the fact that result is assigned to be false, which will cause this check assertion to fail. If that's the case, then we should throw the contract violation immediately, which will cause the whole Boolean query test to fail. Okay, so now, but it's always a good practice to actually do the same check result end after each mini test case, including the last one, because you never know, maybe later on in your development of the test infrastructure, you may want to add more mini test cases, so you don't actually have to type it as one. You just want to make sure every time you have a mini test case, you just add it at the end. Okay, so let's see now what we will get. So now let's rerun the workbench system. So this time, because we actually have added the check result end, we actually got some check assertion violated. So it does cause, because one of the mini test cases actually failed. So now we know that the entire test case actually failed because one of the mini test cases failed. But since we actually put two check result end here, but do we actually know which one actually failed? It's very easy to find out. Let's simply just click on run rather than run workbench system to see where the contract violation occurs. If we click on that, it's going to stop at exactly. So this is actually the view we're going to explore in just a minute, maybe in the next tutorial, to show you how to use the debugger and the breakpoints, but this is a very good preview for that. So when we click on run, if there is no exceptions or there's no contract violation, then it will just run like normal. But if there's any contract violation, like in this case, a check violation occurred, then it will stop at where the contract violation occurred. So don't worry about the objects panel here. We will talk about that in the next tutorial. But here, let's focus on the feature view here. So here, this is the test account creation of the test account class. So this is the context we are in. And now you can see that there's a green arrow here. So this shows you this is where the check assertion failed. If you actually just put your mouse over there, you can see that it shows you the result is actually of value false. That's why it actually causes the check assertion to fail. And to actually show you the same information here, you can see the objects view. So this actually shows you a snapshot of the state space. So what's the current state up to this point, exactly at this point. So we can see that over there we have the results because this is a Boolean query we are talking about. So part of the state space is its result value. So here we can see the result has the value false. And that means the mini test case, which is here, has failed. So here we actually can see this is where the problem is. So if you're now actually writing a single test case, maybe with 10 mini test cases, you can see how convenient this check assertion is because it will actually bring you to where to the first mini test case that actually caused the whole test case fail. Okay, to actually exit from here, we can just go to stop the execution. Okay, let's do that. Okay, so we are convinced that this check result and mechanism is really the right way to make sure that no results of the mini test cases will be ignored if they failed. Okay, let me just fix this and change that to 10. Compile. And then let's rerun the workbench system. And now we do have a green bar. Okay. So now, as I said before, there are two possible ways for a ways for a Boolean test query to fail. The first is if there is no contract violation, but the last assigned value for the result is actually false, then the test case fails. And the second possibility is if there's any contract violation in the middle of the course of the body of implementation for this query actually occurred, if there's any contract violation, then it will also be considered as a failure. What we have just seen is this is one possible contract violation, which is like a check assertion for mini test case. However, we might have other possible ways of contract violation. So in total, we got 3 possibilities of contract violations in the middle of the execution. One is the check assertion, as I'm highlighting right now, and the second one is the precondition violation. So remember now, currently we are in the context of test account and its feature test account creation. So now we are in the context of this feature. Since this feature is now using the service from the account class, so test account creation is the client of the make feature. And the make feature from the account class is the supplier for the test account creation. So as you can see, I keep emphasizing to clarifying the roles of the client and the supplier because it's very important for you to know. And from the client's point of view, it is the obligation for the client to make sure right before I call this make feature, the make feature's precondition is satisfied. So that would be the obligation for the clients. And on the other hand, for the make feature, it can actually safely assume that the precondition is going to be respected by any potential clients. So that would be the benefits for the make feature. So that's for the case of precondition. But since I said before, because make is actually a constructor. So let me just remind you, if we go to the account class, and make is declared as one of the constructor. So usually for constructors, we have no preconditions. We only have postconditions. The reason that a constructor has no precondition, that is because right before the object is initialized, it is simply void. So we have nothing to assume about we can assume nothing about the objects. The only thing we can assert from about a constructor is to make sure upon its termination, we can establish both the postcondition and the invariance. Okay? Nonetheless, so later on, we are actually going to see we will call different features from the context of the test account class. Maybe we'll say test withdraw. In that case, if we are trying to say acc.withdraw some number, in that case, of course, the test account creation as the client must make sure right before it calls the withdraw feature on the account, the credits is actually sufficient. So that will be the obligation for the clients. Okay, we'll see that example in the later tutorial, not this one. Okay, however, in this tutorial, we can see an example of we might have some possible postcondition contract violation. So this is the third possibility. The first possibility is the check assertion violation, and the second possibility is the precondition violation, and the third one is a postcondition violation. And for the postcondition violation, because make is actually the supplier of the test account creation, so it would be the obligation for the make procedure to make sure if this make is executed, then the postcondition must be respected. Okay? And it would be the benefits for the clients in the sense that if I try to call this service here, I will certainly get the resulting states up to this point. So upon the termination of this feature call, I should really get a resulting states that is respected by the postcondition. And me as a client, when I look at the account class, what I care is the contract view, as I actually showed you in the previous video. Let me show you the contract view here. So if I look at the constructor here, me as a client, as far as I'm concerned, I only care that if I call this make feature here, since there's no precondition, so I can always call that. If I call that, then it's guaranteed by the supplier, which is an account class, that the balance will be 0 and the credits will be A credits. Now let's switch to the side of the supplier, which is the account, in which case we have to look at the code. Okay, now in the account class, which is the supplier, now because this is the benefits for any potential clients of this account class, like a test account. So it would be the obligation for this supplier to make sure when the implementation body is executed, then this here must be established, and also the invariant as well, as of course, because the invariants are basically the business rules or requirements that the customer is concerned about. Okay, so again, the obligation for the supplier is to make sure these two lines of implementation will establish the postcondition here. Okay, that means if somehow the supplier did not do the good job on implementing their make feature, that will actually cause a postcondition violation, and this should be able to be caught in here by a postcondition violation. Let me demonstrate what I mean. So let's say somehow the supplier is very poor in developing the software. Somehow it actually got something wrong here. So instead of assigning a credit to, instead of initializing the initial credits to be A credits, they actually initialize that to be A credits -1. For example, let's say if we try to initialize a credit with 10, but he will actually initialize the credits with 10 minus 1, which will be 9. As you can see, if this implementation here would not establish the post condition here, because this post condition here appropriately captures what's intended to be achieved, because a credit should correspond to the a credit here, but the implementation wouldn't establish that. Okay, let's save and compile, and let's go to the test account. Okay, so now this time we should expect the test case to fail again, but for a different reason. Okay, before we actually failed the test case simply because we used to have this, and the reason that it failed is because we failed a mini test case here, right? But now this is our correct expectation. We as a clients of the account class, we expect if we assign 10 as the initial credit level, then we should really expect the credits to be 10 afterwards. However, because the supplier did not do the good job in their secrets implementation, so it's going to violate our expectation. So we will see some post-condition violation. Let's see if this is really the case. Let's recompile again and run the workbench system. So now we have a red bar, as you can see, and we do have a post condition violated. But let's to be sure what's really the post condition that's being violated. Let's close the web browser, and now let's simply just say run. And remember, if there's any contract violation occurring, the IFO runtime system is going to stop at the point where it occurred. Let's say run. And now we are entering here the debugging mode. So you can see that the green arrow again, it stops at where the contract violation occurs. So this is exactly the point where the post condition was violated. So somehow you can see this body implementation here did not satisfy this post condition here. And so here is the call stack, and it actually shows you credits properly set. So that's actually what I said before in the previous tutorial. It's always a good practice to actually give a tag to your post condition, so that when you actually look at the debugging mode, you can actually see very clearly what this particular post condition is supposed to assert. Okay, so now you can let me show you one more thing. So you can see that. So this is also a little bit preview of the next tutorial, but it'll be worth doing it. So here we can see that. So this is the objects view, like a snapshot of where we are of exactly. So at this point of time, so this is the snapshot of the state space. We can see first, because it's a make feature which has an argument. So let me just expand this a little bit. So you can see that we have an arguments tab bookmark here. You can see a credits is 10. It's simply because we can actually see the call stack here, because we actually, so let me expand this here a little bit. So you can see so the make was actually called from the test account feature in the account class, the test account class. So this is where we actually try to manipulate the account object, right? And from there, we actually go to the make of account. So make sure you really understand how we actually switch the context between test account and into account. Okay, so now in the test account context, we are passing 10 as the argument value for the make. So that is why when we go to the context of that make, we can see that argument value for a credit is 10, right? That's certainly expected. But now you can see that somehow with the 10 as the credits, we should expect the current value of credits to be 10. But however, if you put your mouse there, it's actually 9. Or you can see from the objects view. So for the current object, it's going to show you the current object refers to account, which is, if you go back, which is the ACC. So ACC is indeed the current object in the context of the account. You really have to make sure you understand this. Okay, so now here the post condition says the current value of credits, which is 9, is equal to the argument value of a credits, which is 10. Apparently 9 is not equal to 10, so this is false. So why do we actually end up with credits, the current credit being 9 instead of 10? So when we are debugging the code, we should be able to see the credits is actually has been updated not in a proper way because we are subtracting 1 from a credits rather than just assigning that into credits. So you can see, yeah, so this is just a way for you to see the current state space for the as a snapshot. Okay, right. So that's how we actually can observe why the post-condition violation occurred, and you should really try to run the debugger, try to reproduce such violation yourself and convince yourself why this is such violation for the post-condition. Okay, let's stop here. And so how do we fix that? Because we know we actually have deliberately made the post-condition violated simply because we have deliberately made a wrong implementation. So at this point, we have some post-condition violation. And who should be blamed? It should be the supplier, which is the account class, to be blamed. Because we as a client, we only know, oh, I highlighted the wrong line, sorry. It should be this line. So the post-condition violation occurred in this line for the make feature. So we as a client, we call the make feature, and we should expect the credits to be updated properly. But it has not been, so it is not our fault. It is the supplier's fault. So now we should go back to the supplier side and fix the implementation. So let me just fix that. So this will be the correct implementation. And recompile. And now let's run it. And we get a green bar again. Okay. Nope, I don't want to exit iFlow Studio. Okay. That's basically pretty much what I want to say about this tutorial. Let's recap a little bit. So in this tutorial, I'm actually showing you for a single test in the test case in the test clause, for a single test case like test account creation, we may have more than one mini test cases to. So each mini test case will reassign the value to the results, which is a Boolean type. And to make sure the intermediate results for the mini test cases are not ignored by being overwritten, you have to put a check result n. This is simply because when this Boolean feature is used as a test case, there are 3 possible ways to fail the test case. The first way is to have a contract violation. And the second way is when you have no contract violation, but the final result value is actually false. And there are 3 possible ways to have a contract violation. The first one is if you have some check assertion. That's exactly why we actually are adopting this mechanism for the mini test case. So the first possibility for contract violation is check assertion error. The second one is precondition violation. If we are trying to call a feature, let's say, for example, if we are trying to call a feature here, but the feature's precondition is not satisfied, then it is our fault as a client because we are not cautious enough to make sure we only call the feature when its precondition is met. And the third possibility is when the postcondition of the postcondition of the feature is not met upon the termination of the feature execution, in which case it is not our we are not the side to be blamed. It should be the supplier to be blamed because the supplier, it is their obligation to make sure when the feature is called, the post condition is respected, is established. And similarly, the classic variance is also the responsibility of the supplier to make sure whenever you call the feature for execution, both the postcondition and invariance are properly maintained and established. Okay, so you really have to rerun all the examples we have shown you so far and try to reproduce them and make sure you understand how a single test case can fail due to different reasons and why it really passed for the good reason. Okay, so in the next tutorial, we are actually going to show you whenever you see a red bar in your test report, in the HTML test report, so how should you go ahead and find the bug using the breakpoints mechanism, and how you can debug your code by using the breakpoint, by using the debugger mode, debugger view, which we have seen a little bit already. So we'll do that in the next video tutorial. Stay watching.